Welcome to Chapter 5, Writing Linear Equations. In Chapter 4, we did a lot of graphing of linear equations, and Chapter 5 is kind of the reverse. So whereas in Chapter 4, maybe you looked at an equation and then you came up with the graph. In Chapter 5, you might be looking at a graph, or you might have some information about a graph. You're going to work backwards to write the equation. So it's kind of the reverse of where we just came from. So in your first section, you're going to be writing linear equations in slope-intercept form. And hopefully you all remember what slope-intercept form is. That's when we're talking about y equals mx plus b. And this has four components, right? The x and the y, well, x is always the input, and y is always the output when it comes in this order. But what about the m and the b? Well, you remember that the m is the slope, right? And there were a couple different ways of finding the slope. You could use rise over run. You could also use the slope formula, m equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2, right? So m is the slope. And then b was the y-intercept, and that's where the graph crosses the y-axis. So you're going to be utilizing all of that knowledge to be able to to be able to write the equations for the graphs that you see. And this first section is going to be pretty easy. It's going to throw graphs at you, and you're going to work backwards to figure out the equation. So I just want you to follow along at the basic process, and then you're going to get some opportunities to practice this on your own. All right, so you notice we have a graph here in front of us, and the goal is to be able to write its equation. And there are a bunch of different forms for linear equations. You have slope-intercept form, you have standard form, you have point-slope form. We're going to talk about all of those this chapter. But the one I want you guys to work with tonight is slope-intercept form, the y equals mx plus b. So the first thing you're going to do is you're going to pick 2 points. And you want to be a little choosy about where your points are located. You want to find points on the graph that cross your background graph paper at blue corners. In other words, you don't want to come up with these fractional values. If it's possible, you want to find the whole number intersections where the black line graph crosses the sort of blue graph paper background. And these could be 2 examples of that. So I might choose these 2 points. Maybe you chose 2 different points, but as long as they're at blue corners, this should work out. So that point on the upper left is 0, 3. And the point on the lower right is 3, 2. Okay, what do you think I'm going to do with these 2 points? Well, I'm going to use them to figure out my slope. If we want to write an equation in slope-intercept form, we need to know the slope and we need to know the y-intercept. Always 2 things. So how do I use these 2 points to determine the slope? Well, you could use rise over run, or you could use the slope formula. Either way, you should end up with getting a slope for this particular graph of negative 1/3. Notice that it's up 1 over 3 to get from the bottom point to the upper point. And when you go up, it's positive, but when you go left 3, it's negative. So that's negative 1/3. Or you can plug it in the slope formula like you see down there in quadrant 3. This guy's a y1er, so he went y1 minus y sub 2 over x sub 1 minus x sub 2. That also spits out negative 1/3. I like that slope because the negative implies it's going down the roller coaster, and this is definitely going down the roller coaster. The 1/3 implies that it's gradual, and this guy definitely has a gradual slope. Okay, step 3, you're going to determine the y-intercept. Okay, this should be pretty easy. Take a look at the black line graph. Where does it cross the y-axis? Okay, well, it crosses the y-axis at 3. So we say that the b value equals 3. So the slope, the m, is negative 1/3. The b is 3. And then you just need to plug them in to the form y equals mx plus b. So to write the equation, plug them in slope-intercept form. And when you do that, you end up with y equals negative 1/3 x plus 3. Okay? And if for some reason I just lost you on that, just notice that we're always going to follow this format for tonight. Y equals mx plus b. Okay? The m here, that's your slope. That's why we wrote in a negative 1/3 right here, because that was the slope of the line. The b here, that's your y-intercept. The graph crossed at positive 3. So that's why I write in a positive 3 right here. So two things you need to know to write an equation. You need to know the slope and you need to know the y-intercept. Okay, we'll come back to practicing that here in a little bit. Let's apply this a little. Okay, so if we were to apply this to a real-life situation, typically when we talk about the slope, that's often a rate of change. Okay, so if you're trying to take a situation and write a linear equation that might model it, whatever that rate of change is, okay, that rate of change over time, that's the number we're going to use for the slope. The b value, the y-intercept, okay, that's represented by the initial amount, or whatever amount we started with. Okay, so the amount you start with, that's your y-intercept. Okay, you'd plot that point on the y-axis, and then according to however it changes, that number you're going to use for your slope. Let's take a look at an example. It says the number of trout in a lake was estimated to be 44,500 in 2012. During the next 10 years, the trout population is expected to increase by 3,200 per year. Okay, so you're given some information there. But hopefully by reading this, you can start to maybe conceive, okay, which one of these might be an initial amount and which one of these might be considered to be like a slope or a rate of change. I want you to do two things with this. Okay, the first thing I want you to do is I want you to model the population, P, for any year T after the year 2012 with a linear equation. So we're going to use this information to write a linear equation. And the second thing we're going to do is we're going to use that equation to predict what the trout population is going to be in 2019. All right, and we can go through this one together. All right, so first things first, anytime I'm writing an equation, I like to write down y equals mx plus b. Because even if I'm lost and I'm not sure what to do, I know that I can write an equation in slope-intercept form. I just need to come up with some values for the m and some values for the b. Okay? And I also need to understand what this p and t thing going on is, but we'll come to that in a second. Let's talk about the slope. If you look up at the problem and you look at those numbers that they throw at us, which one of those is a rate of change? Which one of those do you think could be the slope? Is it 44,500? Is it 2012? Is it 3,200? Well, it says increase by 3,200 per year. And that per year indicates rate. So that's like it's going to go up 3,200 and over 1. Think about that. You're moving over 1 year on the x-axis, it shoots up 3,200 fish. Go over one next, like the next year, it's going to shoot up another 3,200 fish. So this guy is going to be our slope. Okay, if that's the case, what do you think our y-intercept is going to be? Remember, the y-intercept is the starting amount. So how many fish, how many trout did you start with in the lake? Well, that's the big number here, the 44,500. Okay, so if I know that, I can go ahead and write an equation right now if I wanted to with the y and the x. So y equals 3,200x plus 44,500. And most likely if you wrote this, I'd probably give you some partial credit, but we didn't really follow all of the directions exactly. If you go back and read part A again, it says model the trout population P for any year T. So they're actually telling us what variables they prefer us to use. That means you need to figure out which one of these would be like the y and which one of these would be like the x. And remember, the x is the input, the y is the output. So is this a situation where we, plug in the number of fish to figure out the number of years? Or does it make more sense to plug in the number of years to figure out the number of fish? And it's actually the latter, okay? This t, the number of years, that's your input, which is going to be like your x. And once you plug in the number of years, you're going to do some multiplying and some adding, and it's going to tell you how many fish are in the lake for that number of years. So your p, the population, that's your output. And that's going to be like the y. So final answer, instead of writing y and x, we want to exchange these for the other variables. So I'm going to exchange that y for a p, and I'm going to exchange that x for a t. And that would be the appropriate model. Okay, so that's part A. Part B says predict the trout population in 2019. Okay, now this one I want you to maybe do on your own. Okay, so try this on your paper. You're going to have to plug in something for t. And it's giving you kind of a hint here, knowing that we're going to try to predict ahead a certain number of years for 2019. So why don't you go ahead and try that on your own. If you need a calculator, go ahead and grab one. Hit pause, and then unpause when you're ready to go over the answer. Okay, well, the big deal here on part B is knowing what to plug in. So we've got the model. We just need to know what number to plug in for t. So when I set this up, I might put some parentheses here for the t. Now if you plugged in a 2019, you are going to get a huge number of fish, and you're going to be wrong. Okay? Remember, we're talking about the years after 2012. So for example, the first year after 2012, if I were to plug in a 1 here, you'd have 3,200 new fish, and you would just add that to the 44.5, right? If it were 2 years after 2012, I'd plug in a 2 here, and then I'd have 6,400 new fish, and I'd add that to the 44.5, right? Well, how many years after 2012 are we talking about? Hopefully you plugged in a 7. And the reason you would plug in a 7 is because 2012 is exactly 7 years away from 2019. You would use subtraction here to figure out, oh, we're talking about 7 years from the year by which we were starting at. Okay, so that's where the 7's coming from. Now, this is probably something that you would type into a calculator. Of course, you could do it by hand. But I think if you type this in, the population of trout, I believe, is going to be 66,900. And you want to label that trout. Okay? So hopefully you were able to come up with the correct model along with me and maybe get the 66,900 on your own. All right, let's get into some practice by yourself. First parts of practice, I'm going to give you some graphs and ask you to write the equation. And then in the last part of the practice, I'm going to have you do one of these word problems on your own. So feel free to refer back to the beginning or refer back to the problem that we just did if you need to. All right, do these two together. Number 1 and number 2, it says write the equation for each graph below. And remember, you need to find the slope and you need to find the y-intercept. And if you get lost along the way, you can follow along with me. But try to get these on your own and see what you come up with. Okay, go ahead and hit pause now, and then we'll reconvene to go over answers. All right, let's see how you did. When I do these, it's just like that last problem. I always like to begin by writing down y equals mx plus b. And I strongly encourage you to do the same thing. This will remind you, oh, okay, I just need to figure out what the m value is and what the b value is, and then I'll be able to plug those in and write an equation. Okay, and I'll even write a little note to myself. Okay, figure out what m equals, what the slope is, and figure out what b equals. That's the y-intercept. Okay, let's start with the slope. Okay, I'm going to use rise over run here, I think, and you might have chosen different points, but I'm looking at this guy and I'm looking at this guy. All right, and I remember that slope is rise over run. And that's how I'm going to approach this. Start at the lower point. How many do I rise up? Well, that's going up 2, and up is the positive direction, so I might write down a 2 for my rise. Okay. Now, how many does it have to go over? Well, it runs over 1. And notice that it's going to the right, and right is also considered a positive direction. So 2 over 1 would be my slope. This is an up 2 over 1 situation. So for my slope, I can plug in a 2. For the b value, that's the y-intercept. So where does the graph, where does the red line graph cross the y-axis? Okay, and it crosses way down here. So hopefully you can hone in on that point right there. Okay, this point is the y-intercept, and it crosses precisely at -4. So that would be my b value. And so the equation is simply y equals 2x Now you could write plus -4 and you would not be wrong, but typically we just say -4. And that's a little bit more simplified. Okay? All right. If you didn't get either of these, I would say go ahead and pause again and try number 2 on your own. Now that you've seen how I did it, just follow the same method and see if you can come up with it on your own, because you really need to get in the habit of being able to do this. If you're ready, let's go ahead and go through number 2. Same deal. I'm going to write down y equals mx plus b. I want to know what my slope is, and I want to know what my y-intercept is. Those are the goals for me. I'll start with my slope. And I need to pick 2 points. And notice that they don't have the little nice dots there for me like they did last time. So I'm looking at this guy. This guy pops out to me right here. And this guy right here pops out to me. So those are probably the 2 points I would focus on. Okay? And it's going to be hard for me to show you the rise over run, because it's a little tight in here. But starting at that lower point, how many do I go up? Well, looks like I go up 1. I go up very little, so it's just 1 square. And it is in the positive direction. But for the next one, I go over 1, 2, 3, 4. And that was to the left. And that's kind of the negative direction. So I would think of that as like a -4. So my slope is 1 over -4. And another way of saying that is -1/4. I like that number because I notice this is going down the roller coaster. It should be negative. It's going down gradually, so it should be a number like 1/4, something that implies gradual slope. Okay, where is my y-intercept? Okay, and I'll do this in black. Okay, my y-intercept also happens to be one of the points that I initially circled. It happens to be this guy right in here. So my y-intercept was at that point, and that was +3. So my b value is a 3. And I use this information to write my equation. So this guy is y equals -1/4 x plus 3. Once I have that equation, then I could come up with any combination of x and y I want. I could know what y is when I plug in a 100 for x, and I could extend this graph as far as I wanted to on into infinity. So coming up with the general equation in slope-intercept form is really good for input and output. Okay? I hope that you got these. If not, maybe you're getting the hang of it. Let's try a few more. Now notice these are blue examples. Of course you're writing these down. Don't feel like you have to have graph paper because I'm giving you the graph. You just need to have regular paper for these and showing all of the steps, all of the work that you're doing. Also, if you want to take good notes, yeah, you might sketch a drawing of these. Sketching the drawing is not required, but you might want to come back and watch the video if you're not sketching the drawing. Okay? All right, so numbers 3 and 4. You'll notice that number 4 is missing a graph, so I'm going to go ahead and put that in right now. So let's see, for number 4, let's try we'll try that line. Okay, go ahead and try both of these on your own. Remember, y equals mx plus b. You need to come up with a slope and a y-intercept. See if you can get the equations for these lines. Go ahead and hit pause now, and then unpause when you're ready to reconvene and go over answers. Okay, on number 3, I tried to give you a somewhat nastier slope. So I know I need to find my slope, and I know I need to come up with my y-intercept, and then I can get my equation. Let me start with slope. And you can see you have the 2 points there. So I'm going to use rise over run. My rise is up 1, 2, 3, 4. And that's a +4. So for rise over run, I'm thinking +4 on top. My run is 1, 2, 3, 4, 5 to the left. So that's kind of like a -5. So -5 for my run. So my slope is going to be -4/5. My b value is the y-intercept, and the y-intercept happens to be at this point right here. Okay, so that is positive 3. So here b equals 3. And I can record that down below. B equals 3. To come up with the equation, it's just going to be y equals negative 4/5 x plus 3 or minus 3. Well, it's above the x-axis, so it's plus 3. There you go. Okay, hopefully you got that one right. Number 4, I'm not trying to trick you, but you should be able to come up with the equation for this line. And if you tried to do it in terms of slope and y-intercept, that's okay. That might actually lead to a deeper understanding of all of this. Well, what would the slope be? If you picked any 2 points, let's see what that looks like. Okay, what's the rise to get from one of these points to the other? Well, you're not really going up or down anywhere. You're kind of staying put. So you're moving nowhere. You're going 0. The run, well, in this case, it's 1, 2, 3, 4, but it really could be any number you want it to be. I could have picked any 2 points, right? The point here is 0 over anything is 0. The slope is 0. And you should remember from our discussion with the roller coaster that the slope of a horizontal line is always 0. Okay, so my slope is 0. What about the y-intercept? Where does it cross the y-axis? Okay, well, it crosses the y-axis right here at positive 5. Okay, we know that this guy is the y-intercept. So 5. And if you were to write this as an equation, you might write down y equals 0x plus 5. It's a little goofy, though. No one really does that, because 0 times x, 0 times any number, is just going to be 0. So we sort of exclude this because it's unnecessary. And that's where we get y equals 5 from. You remember in previous chapters how we talked about the equation for a horizontal line is always y equals a number. Well, this is why, it's y equals a number, because the slope is 0 and we just discount it. So hopefully you're able to make that connection. All right, on to our last blue example. And this one is going to be like the trout in the lake problem. Okay, calling plan to China charges a $1.25 usage fee. That's a one-time fee. And then 8 cents per minute. Model the cost C for the number of minutes M that one remains on the phone during a phone call to China. So the first thing you're going to do on the top is come up with the model and write the model. Once you got your model, then answer the question at the bottom. If you speak to a relative in Beijing for 18 minutes, how much money have you spent? All right, take your time, do a good job. Don't give up. Fight your way through it. Go back to the trout problem if you need to. Go ahead and hit pause now, and then unpause only when you're ready to go over the answers. Okay, well remember, even in this situation, we're still writing our equations in slope-intercept form, so we should come up with something that parallels y equals mx plus b. Okay, the y, that's the output. So do you think the c or the m is the output? Do we plug in the number of money, the number of dollars to figure out the number of minutes, or do we plug in the number of minutes to figure out how much the cost is? That's the question you have to answer. Here, the minutes is going to be what we stick in. So the minutes are going to be the input. C is going to be the output. So C is like the y. M is the slope or the rate of change, and that's the 8 cents per minute. The trick here is how to write it. I would not write it as an 8, because then you're talking about 8 pennies. And that $1.25, that's a different system. That's the system of dollars. And you can't write pennies and dollars in two different systems. We want to express both of these in terms of dollars. That's why we take 8 cents and write it as 0.08, just like you'd see it on a cash register. When you see that, it's not saying 0.08 pennies, because that's a fraction of a penny. It's saying 8/100ths of a dollar. So 0.08 x, but instead of x, we're going to use m times the number of minutes. So 8 cents times the number of minutes plus the initial fee, right? That's your y-intercept, where you start. So you would start at $1.25. You can imagine this on a coordinate plane. Okay, this is just a simplistic drawing, but let's say $1.25 is right here. You're going to go over 1 minute and up 8 cents. You're going to get this gradually sloped graph that's going to be the cost of your call. all right? Starting at $1.25 and then going up 8 cents every single minute. 8 cents over 1 minute. That's up 0.08 over 1 to the right. All right, hopefully you got the model correct, because you're definitely going to have to write models and such. All right, last one. If you speak to a relative in Beijing for 18 minutes, how much money have you spent? So you need to plug in that 18. So C equals 0.08 times 18, 8 cents per minute. And we're talking about 18 minutes, plus the initial fee. And this is probably something I would do on a calculator. Although if you do it out by hand, that's a good thing too. But I believe, if I'm not mistaken, it's going to be $2.69. And hopefully I did my math right there. If not, you can bring it up in class tomorrow. Okay. All right, so good job. Hopefully it made sense to you. Bring your questions with you tomorrow if you need to, and good luck on the assignment.